Hey, welcome back everyone again. So, after a little bit of heavier dose that we have learned here, well, this is quite messy, seemingly very messy to me. So, we are going to study something simpler. That's why I drawn earlier, and here is our benzene. So, let's make the environment a little cooler. So, this is from 0 to 5 degrees Celsius. So, convert it into degrees. So, this is really cool, right? That's why I written it with the blue color. You can notice that color of coolness. So this is aniline or nitrobenzene, whatever you like to call it. So we have it here. Okay, let me change the color so that we can enjoy it a little more. Let's choose a white color. So we have it here. So what we are going to do, we are going to make disonium. So how we can remember the word disonium? Well, it's simple. Wherever the plus and minus charge come together in the N2 and actually not Cl, it's X. So X is surely be negative, this will surely be positive because as X will have X or halogen is having more tendency to take electrons than the nitrogen. Nitrogen wants 3 electrons and X as chlorine, bromine, iodine things want only one electron. So it's not just about the electrons, it's about the protons. It is having 7 protons in its center. And if you are considering the chlorine, like we have considered in our reaction here, so it is having 17 protons. So of course the priority goes to this one. So now that you have learned this one, this is going to be our disonium. This forms the disonium along with the benzene. So benzene disonium chloride. Why chloride? Because we are using the chlorine. Otherwise we have written it halogen. Okay, now what's next? NaCl. Well, table salt, remember? So this is stable, and H2O, the most stable thing on planet Earth, without which we cannot even imagine to exist. So this is all about the reaction. This is the speciality of this reaction is two things. First, we learn about the disonium. Second, it works on very colder environment. There are very less reactions that actually work in that such cool conditions. So let's study its deeper investigative things. So now let's start our detective skills. So you are my Sherlock Holmes and I am your Watson. No, you are my Watson, I am your Sherlock Holmes. Well, does not matter. Let's start studying anyways. So what we are going to learn in this case? We are going to learn in this case that what is formed here is actually this is reacting here. So if you try to form the side products, okay, let me clean it a bit so that we can learn the things quite happily and not with these messy things. Okay, just one more moment and this all the stuff is going to be cleared up. The clutter is getting cleared. Well, who is going to tell me the meaning of the clutter? Okay, let's remove our thinking and pondering body either. Okay, now it's seemingly clear. So let's begin. So as you can see, the benzene is benzene. So there's no change in the benzene here. So what is actually changing? The thing that is changing is N2Cl over our benzene. So this is what is changing. So previously it is only having one nitrogen, now it has two nitrogens. Previously it is having H2 which is unavailable right now. So where that H2 gone? So let's write H2. We need to figure out where our H2 is gone. Now what's next? What is more missing? Na forms with Cl. So NaCl is stable. We got one stable product, NaCl, and one N actually gone with this benzene, so we are covered with this one either. So now we have O2 and 2H, as you can see. And one chlorine already gone here, as there are two hydrogens, so I wrote the two hydrogens, and one chlorine is already gone here. So now let's think very carefully. In combination, we have four hydrogen and O2, which is going to form 2H2O. And yes, exactly, that's what we have formed here. So now every product is stable. NaCl is stable, H2O is very stable in nature. So this is the disonium. Well, that's not the end of the story, of course. This reacts further, but not with these things. So it needs something else. Like if we use the iodine, we can use CuX or something like that. Oh, sorry, Cui. So we can take copper or something else that I'm going to tell you in the last one. But for now, we can say that it will not going to react in these things. So it requires something else. And that's what it meant. So now I think you have learned something new from here, that how the stable products are actually very important in making something undigestably exist. Like in our case, benzene diazonium chloride is unstable, as you can see the charge is clearly on them, but it is not reacting further unless we give it something extra like copper or something like that. If we do not do that, it will have to be in that unstable state till that time. So you are not unstable, you are pretty much stable, but keep on developing. Don't be noble gas, be radioactive, and keep on learning and spreading your knowledge. And let's meet in the next one. So that's it for now. Take care. God bless.